Good morning, and thank you for joining us today. I'm Tom Stroup, President of the Satellite Industry Association, and I want to welcome you to our June webinar, The Resiliency of Satellite Networks. Before we get started, I want to cover one logistical item. We encourage questions from our panelists from the audience, and to ask one, please use the chat feature in Teams. We have a very large number of attendees today, so we've muted your microphones to ensure our program proceeds as smoothly as possible. And this will provide you an opportunity to ask your questions. We have an amazing group of panelists joining us today, including Dave Allen, Solutions Architect Manager, Global Enterprise Solutions with Leonardo DRS, Jose Horta, Business Development Director with Integrasys, and Campbell Marshall, Vice President of Government and International Markets, Omnispace. You can read full bios for David, Jose, and Campbell on our events page of our website at www.sia.org. Earlier this year, we polled our members to request suggestions for webinar topics, and resiliency was an overwhelming favorite of the respondents. That is no surprise, however, since it is one of the key advantages of satellite networks, as well as one of the key requirements of our government partners. In order to kick off our session, I've asked each of our three panelists to briefly describe their company and what they see as the most important problems their resiliency capabilities address. We'll then get into our Q&A with questions that I have for our speakers, and as noted before, we encourage questions from our audience as well. With that, let me turn it over to Dave. And Dave, you're on mute.
Okay, I'm sorry, I wasn't, are we doing the presentations now?
Yes, please.
Okay, I don't see the slides. Am I supposed to be pushing, or are they not going to be presented?
We'll bring them up, Dave.
Okay, thank you. Appreciate it. Okay, hello, thanks for the introduction. And like I said, my name is David Allen. I'm a program engineer with DRS, Leonardo DRS, Global Enterprise Solutions. I apologize about the complexity of this slide as it's put up all at once. Typically, I would build this up through layers and kind of deep dive each layer as it's built up. Just to save time, here it is all at once, but I'll step through this and talk about resiliency in the different layers and our DRS's overall philosophy. So here at DRS GES, we feel that this diagram presents an technology ecosystem where all of the layers from the space segment to the ground segment, the network management, and the enterprise management, user experience, and cybersecurity and information assurance ties together, and we control every aspect of this for our customers. And by using a vendor agnostic approach and not betoving ourselves to any specific operator or technology, it allows us to customize the solutions for each of our customers to find the best fit, best value solution for every requirement. So in the spirit of resiliency, if you start at the space segment, by offering all satellite constellation options from GEO, MEO, and LEO, that provides an obvious resiliency benefit, especially with the capabilities in hardware with terminals now that can do KU/KA or multi-band solutions and switch between orbits with little or no user intervention. Then by providing any orbit of satellite service to our customers, then that provides a lot of resilience there. And then on the ground segment, it's sort of the same thing. The DRS owns and operates our own MPLS network. It is global and dual physically diverse to provide, once again, resiliency to our customers. Also on the teleport side, all of the teleports are vendor agnostic, meaning they are not owned by a specific satellite operator. And what that allows us to do is to point an antenna at any of our teleports to any satellite that's required to make the mission happen. Moving on to the user layer where you see the satellite terminals there is because, once again, because DRS uses a vendor agnostic approach, there's no terminals that we can't support. So whatever our customer wants to bring to the fight in the spirit of the terminal itself or the modem or hub technology, we can develop a solution around that. And of course, when you have options, you also have that enhances resiliency, right? And interoperability between systems and things of that nature. Going down into the network management layer and the enterprise management layer is having more than one network operations center, having COOP sites, provides resiliency, and then moving on into the cybersecurity portion of the ecosystem is, of course, cybersecurity and information assurance is a large factor in overall resilience, and DRS's global communications network. It has a risk management factor rating of medium, high, and authority to operate and connect to DoD networks. And that's how that layer factors in to resiliency. Next slide, please. Lead us up here. I'm not going to brief every bullet here, but I think what this slide represents is a lot of the things that I said on the previous slide, is that it's, DRS's philosophy is vendor agnosticism. What that provides is best fit, best price, best value for every requirement, no matter who the technology belongs to or who owns the satellite. Options provides resiliency. As the owner operator of the core network, we're able to ensure the security and reliability of our users' data and provide best routing. We're also able to ensure the redundancy and prevent outages and things of that nature. I guess back to you, Tom, if any questions.
Okay, great. Thanks, Dave. And thanks for that overview, and good job briefing what I think may be the most complex chart I've ever seen. So with that, I'm going to turn it over to Jose next for his opening comments. Jose?
Yeah, good morning, everyone. My name is Jose Horta. I'm BDD from Integrasys, and the approach I want to make on the issue of today, it's a little bit slightly different. We are not talking about just the integration or technologies, but we are going to talk about which are, from our point of view, the first approaches we should to have in mind, the strongest legs, if we are going to talk about the resiliency. So we have prepared some small slide presentation, very few. So if we can see it in the screen. Oh, thank you. So let's not start by the one. Okay, thank you. So basically, I am talking to a little bit about resiliency in general terms of the networks. If we advance next slide, please, so we can see that the government and military retail revenues are focused increasingly on the geo. Basically, you see all the figures is growing up, but especially we are going and focusing on geo and in all the bands. So we should have this in consideration when we want to deploy the strategies to get resiliency of the technologies and in general terms all the SATCOMs that we have in mind. Next slide, please. Yeah, basically we think that resiliency is based on four big pillars. One is to define a tactical and reliable network design, which is key to make easy the next steps of the resiliency processes. With that, the next step for sure is to have a seamless and robust data exchange that would include any kind of gathering information. We should include and involve latest technologies like big data and all the elements that later on the system integrators should gather and to put it together in the same box. Another leg we think it's important to bear in mind is the increasing the situational awareness processes that nowadays are involving every time of communications, and moreover, the SCADCOM communications. We think we need to be aware not only about the element, the punctual element of the link we have already, but also all the environment that we are moving around with the satellite communications, which is involving a lot of external factors, from additional interference to jamming interference to maybe cyber attacks to reinforce all the Earth segment. So this is a global picture that should be having in mind when you talk about resilience. And obviously, the last pillar is that nowadays all the technologies are getting even and more complex. So you need to have, as we see, we have seen in the slide from Campbell, that the infrastructure is should be very considered because it's very complex. Okay, so next slide, please. So for that, we have a linear way. We have a linear way that we start with the actual business network, which is all the complexity increasingly today with all the elements that are interference and they are adding in the pod. So with that, we need to have a network automation that comes from very different ways and with different technologies. How to glue and how to make such handling of those information is with probably with a virtualization of the solutions that will help everybody to give a global perspective on how to make resilient processes and how to implement resiliency in every point of the value chain or the communication line. With that, for sure, our aim is to add another value by using AI. The using of artificial intelligence gives the necessary at our consideration perspective to have a global view with the roughest possible technologies and the evolution, and to be able to do not only solve problems but also predict and avoid future problems or evolution in the scenarios. And all of them put together in a linear way, we will try to get and we will achieve a resilient network, because we are applying every single point of what I've just mentioned in all the elements and all the chains or the points of the chain that involving the VSAT communications. Okay. Next slide, please. So for that, the challenge that we have, we want to implement a resilient network with the pillars we have just commented before, are basically the ones we see in the screen. We have to start with a network design, a reliable and a robust network design, analyzing different scenarios, analyzing different footprints. So for that, we need to have a very good tools from the design and engineering point of view, to have a link budget calculation tool, which could be very tough, which will allow a lot of different consideration and scenarios. Also, when we have just to make the design of the network, we have to go to the next step. At least I'm talking in the ground segment, which is the auto-commissioning. The auto-commissioning on the installation on the network should be as much as automated as possible, because with these features we could avoid any outsider inputs like human error or mishandling or unintentional, non-intentional actions from the commitment and installation. Once we have deployed the network, the next point is to have a reliable and robust monitor and detection systems that could detect interference, that could detect any external action on the quality of the communications we are driving. And later, once you detect interferences or if you detect an abnormal behavior of the communications, yes, you need to take actions on that. which is mainly the interference elimination once you have detected. For us, these are mostly the main points to get a resilient network. Next slide, please. So if we have to concentrate in just a sentence the how to achieve our resiliency network, at least in the ground segment, we will definitively be for the network automation in every single point of all the value-added chain that compounds all the telecommunications by satellite. And from my side, I think that's everything. At least this is the first round to put things on the table. Back to you, Tom, again, and thanks by the time.
Great, thanks, Jose. So our next speaker to provide opening comments is Campbell Marshall. Campbell, over to you.
Hey, good morning or afternoon, depending on where you are. Thank you for the opportunity to participate today, Tom, and everybody else at SIA. Great event. So I'm with Omnispace, as Tom mentioned. Omnispace, well, hopefully this will sort of give an interesting, slightly different perspective from that of Jose and David, in that Omnispace is doing it from the perspective of a group that's building a new architecture. It's building a very different approach to a new satellite constellation, and really, I should say, new communications architecture. And wait for my slide to come up as well. Omnispace is building a new network, and I'm going to speak a little bit to who we are, just so folks understand sort of what we are, as many of you might not have heard of us, and then make a couple of brief points in terms of how we think about resiliency. But we are a company that's building a new global communications constellation that integrates the capabilities and the reach of satellite together with the power and existing infrastructure of terrestrial networks, 5G terrestrial networks. And we're focused on a standardized approach, standardized chipsets and standardized 5G approach, 5G non-terrestrial network, or NTN to be specific. And in creating this capability globally, we believe that this will play a really key role in enabling small devices, IoT devices, and handheld communications devices that will inevitably be connected in 5G networks terrestrially, to have the capability to roam seamlessly wherever they go. And obviously those devices, whether it's your Tesla or a warfighter's radio, as they move in and they start to integrate the advantages of 5G technology, they're going to want to connect outside of cities. Our warfighters and communications devices commercially, as part of Industry 4.0 as it evolves, aren't only going to want to operate in urban areas where there's MIMO antennas. They're going to want to operate in other areas as well, in the middle of the ocean or the desert or the mountains. And so we're really focused on creating that connectivity capability worldwide. And the way we do that, next slide please, is we combine, as I said, the reach of satellite with the existing power of terrestrial 5G networks through our global 2 gigahertz S-band spectrum. And so we create partnerships with mobile network operators around the globe. And in effect, we are able to provide the usage of that S-band spectrum in the terrestrial networks when those devices are in those blue bubbles you see there in urban and terrestrially covered environments. And then they're able to switch seamlessly, very small IoT type and handheld devices would be able to switch seamlessly over to our satellite network. And we believe that this flexibility implicitly creates a whole lot of resiliency in any number of manners from an NGSO constellation. This is actually where Omnispace was founded by the same folks who created Sirius XM radio, which a lot of people are probably familiar with in their cars, which operates in a very similar manner. When you're in a city, you're listening to a terrestrial network, and when you leave the city, it switches seamlessly on the same device in your car, same frequency, over to a satellite network. And so Omnispace is taking a similar approach, but instead of doing music in the United States, we're going to do data globally. Next slide, please. And all of this really comes down to, at its heart, and we believe that this really speaks to the future of resiliency, as a standardized approach, an industry standardized approach that really comes down to something like a standardized chipset. So a 5G chipset is going to be critical both commercially and militarily to building resiliency into networks, because when you have a standardized approach and you're not relying on one provider or another provider's different way that they connect to their network or the way that they switch between networks, when you take a standardized approach, that implicitly creates a whole lot of resiliency across the network. And so we believe that is going to be key. Next slide, please. So just generally speaking, the way we sort of think about resiliency is we're architecting our next generation network, and we have assets on orbit now. We're building new ones in the interim, and we're focused on a full 24/7 coverage through an NGSO constellation. But the way that we approach resiliency is through flexibility, as already mentioned. The hybrid aspect, terrestrial and satellite, creates flexibility, which we believe is first and foremost a part of resiliency. A diversity of orbits. So each orbit has its own advantages, and we can get into that a bit later. But we believe that diversity implicitly creates resiliency. Difference of constellations, so operators can operate in different types, whether it's a government constellation, a scientific or a NASA constellation, or commercial, obviously. Leveraging different frequency bands, both the ones that government or commercial would have traditionally used, but also getting into different bands creates more optionality. Allocation of usage. So government traditionally has not been, let's say, so good at making sure that the right application was riding in the right frequency, or inefficient use of different types of carrier or transport. And getting better at that, we think, is key. And the last one that I would mention is sort of part of, again, as I've already mentioned previously, 5G. It's implicitly in the standards are going to have all kinds of new capabilities, whether it's in cyber protection or the flexibility to do different things within the same amount of spectrum, much more within the similar amount of spectrum than you could traditionally do. And we believe that both commercial and government customers would do themselves well to take full advantage of those capabilities as 5G and then beyond begins to become part of what everyone is using. Thank you very much, Tom. Look forward to the discussion.
Great, thank you. Excellent overview by each of our speakers. Let me start with some questions, and again, I encourage members of our audience to go ahead and jump in via the chat feature with any questions that you have. But let me start with, what do your customers feel are the most important aspects of a resilient network? And is there any difference between your commercial and government customers? And let me start with you, Dave, and then I'll go through the same order, and then we'll reverse the order for our next question. Dave?
All right, thanks, Tom. I think what our customers feel are most important to the aspects of a resilient network can be broken down in 4 major categories without going into detail of each. They want high availability and reliability. They want diversity and the options to dynamically change the technical solution when needed. They want security, cybersecurity and information assurance, and lastly, swift recovery and resolution of issues. And I think overarchingly, there's not a major difference between what the commercial and government customers want or need. I think, of course, when you start getting into the government side, there's some special considerations of how their networks or satellite communications might be affected by adversary actions and things of that nature. But at the core of it, interference is interference, and cybersecurity is cybersecurity. So I feel like there's not a major difference between the end goal for commercial and government customers, Tom. Over.
Great, thank you. Jose? Jose, you're on mute.
Basically, as I was saying, I fully agree with Dave. I will add just one question. What people expect as well is to make life easy. They want to have resiliency, but they want to do not have very, very complex procedures. They just want to push one button and talk or see or whatever. And relying on the technology, all the hard work of doing all the paperwork and to have all the resiliency and all the elements of cross-checking, of encryption, of IoT considering, big data management. And so For me, I think that's a line that people will demand. Other issue is that this would be feasible or not, or it's easy or not. But I think nowadays things are relying a lot in the technologies that are being implemented. So this could be a line of interest for future considerations. Okay, over.
Great, thank you. Campbell?
Yeah, thanks, Tom. And it's hard to follow those. I totally agree with everything that both Jose and Dave just mentioned. But yeah, so commercially, I think, it's pretty straightforward. We're engaged with mobile network operators around the globe in building our network, and really it's pretty straightforward most of the time. It's they want 100% availability 100% of the time from the network, which also means healing the network appropriately when you have outages, and I think it's pretty straightforward in my opinion that's kind of the demands or the aspects of resiliency for the commercial folks, and for them it's a little bit easier because terrestrial you can get your hands on it pretty quickly in order to fix something, but obviously with the satellite that's a little more challenging. And I think the commercial sector is a little more used to having outages or challenges with satellite communications or SATCOM. Governmentally, I think it's a bit more nuanced, and we've been working a lot with SMC and getting hearing sort of the amazing work that they're doing on flexible modem interface and enterprise management and control capabilities. It's similar to commercial, but in this case, of course, lives depend on it, and they're always the first ones to tell you that, and as they well should. They traditionally, I think the government would take the approach that it required exquisite tailor-made systems in order to ensure 100% availability, but I would argue that that's evolved a little bit. Commercial systems are now more reliable, in large part because of the commercial volume that they increasingly have. And so, if you're at scale and you have more customers, you're more aware of outages or issues, and then you learn as you go and you make that network more resilient in that manner. So I think government is learning to sort of trust commercial a little bit more in that respect. And again, I would hammer on flexibility being a key aspect of what they're looking for. As I mentioned, SMC is really focused on flexible modem interface and FMI and EMC. We've heard so many times that the warfighter in the field should not have to think, oh, I can't connect to A, I need to swap out to a different radio, set up a new antenna, all those kinds of things. The warfighter should be focused on what's in front of them, and their radio should be the least of their concern. And so we hear a lot of that. So agile ability to go between systems is really critical, and we have that sort of front of mind. And the last thing I would mention is the needs of the warfighter are evolving, and that's based on the evolution of both their technology, but also adversarial technology. And, as we see the overall JADC2 Joint All-Domain Command and Control CONOPS sort of coming to light and coming clear, that's going to continue to evolve, and more things are going to want to be connected everywhere. And so resiliency means the ability of those things to seamlessly connect regardless of where they are, and making sure that both the folks in the field and the command elements can reach out and gather the data that they need and provide it to the people who are out at the edge in an efficient and reliable manner.
Thank you, Campbell. Let me ask a question really on a follow-up to many of the things that you mentioned, and that is resiliency now a more effective strategy than survivability? Let me start with you, Campbell, and then I'll reverse the order. So.
In a word, I would say yes. I do think it's a more effective strategy. I think you could argue that it's the evolved version of survivability. Technology has changed, architectures are changing, and at sort of Murphy's Law, or I forget the name of the chipset hockey stick, but they're evolving at such a rapid pace that absolutely, and we're honored to be working with the Marine Corps on a number of things. And as the Marines will tell you right off the bat, especially when they're talking about comms, they work off of the PACE acronym or the PACE mantra, which is, always PACE stands for primary, alternate, contingency, and emergency. So they literally, any good Marine will always have 4 options for any one objective. And that includes for comms capabilities. And so they always plan for the worst and assume that, 1, 2, and 3 are going to fail and you're going to wind up on option 4. So I think that's a great way to think about that question, evolving to resiliency versus survivability. Because if you assume that it's got to survive, you're just sort of dooming yourself for an unfortunate ending. Whereas if you assume that you're going to wind up on option 3 or 4, you're ready for it. And so I think that's sort of how we think about resiliency in that regard.
Great, thank you. Jose?
Yeah, but again, I agree with Campbell. For me, survivability is a very short-term life. If you go for resiliency, you are taking the initiative to let's say to win the battle. In terms of survivability, you are just defending, just trying to stop whatever threat is created, and do not take the initiative in avoid scenarios and in create your own scenario in which your technologies will allow you to live and to live in a much more secure way. So for me, definitively, resiliency is the bet, much more larger than survivability.
Great, thank you. Dave?
Yeah, I think I agree with both of the other gentlemen is that specifically for government applications, a conflict with a near-peer adversary is almost impossible to prevent disruption or elimination of a singular asset. Whereas through resiliency, if you drive down the cost of the satellites and the technology by not overemphasizing survivability, then it allows for high proliferation of those assets. And so I think Campbell was saying is that options provides resiliency. So we're able to put more spacecraft in orbit or have more gateways on the ground. That provides a more effective strategy, in my opinion, than relying on the fact that you can protect a singular or a few different assets from a bad actor.
Great, thank you. So let me turn to design of networks and architecture. So is there a way that satellite systems can be designed to be more resilient? And I know this may be more applicable to Dave and Campbell's businesses, but Dave, let me start with you.
I think that kind of one of the things I touched on in the last question is proliferation and reconstitution capability. It's usually achieved through cost-effective designs, but I think that is definitely a way that satellite systems and constellations can be designed to be more resilient, right? We've been talking about options during this entire panel. And then also in the technology side of things, I think that there's a lot of exciting things coming that will enhance resiliency, sort of the optical inter-satellite links, to be able to route across the space segment and avoid perhaps a region on the terrestrial side that might be unavailable due to conflict or a widespread power outage or something like that, and downlink at a different location, as well as software-defined satellites, with beamforming capabilities, whether those are manual or automatic, allows you to cut out interferers, by reshaping the beam or around that problem. So, and I think that the last thing there is also, sort of touching on some of the capabilities of the newer satellites that would be coming over the next decade is, I think, what we see is transponders that are not fixed to specific frequencies, like on the legacy GEOs. And when you have frequency diversity over a geographic area, that gives you a lot of resiliency options. Thanks.
Great, thank you. Campbell?
Sorry, I had to find the mute button there. Yeah, I'm gonna jump right on the last thing that Dave mentioned. We think that especially with the proliferation of LEO and NGSO satellites happening, inter-satellite links are just critical, and even optical inter-satellite links. DARPA through Blackjack, SDA is reflecting this through their work on OISLs. that really is a critical aspect of new architectures for all the reasons that Dave mentioned, and I won't repeat, but I would add on that, you know, when you have differing demand signals, especially if you're getting into using a dual use constellation that may have a high volume of users in a particular geography, if you design a system that doesn't leverage significant ISLs, you might get yourself in a scenario where you get very capacity constrained very quickly. And especially with the huge volume satellites are going up in some of these singular constellations that we're seeing, having those ISLs is really critical to kind of cross-load traffic. Another, you know, two other quick things that I would mention in terms of architecture is the ability to leverage these advanced protocols, 5G, et cetera. Some of this incredible work that's being done by both government and private stakeholders in terms of developing the capabilities of 5G. These things, you know, these protocols and these technologies have the ability to build in so much more sort of healing and resiliency and the ability of the network to adapt in the same amount of bandwidth that we traditionally would have had. To pack more capability in, I think, is really critical. And then the last thing that I would mention is diversification of orbits. I mentioned briefly right up front. Each one has its advantages. Government knows a lot about traditional geo orbits, but it's geographically confined as we look to operate more and more in northern climes. But it's nice because it's harder to hit, and only sort of the big operators, if you will, big stakeholders can get to geo. LEO is obviously the issue du jour and where a lot of people are going, and it has a lot of fail fast and spiral development advantages to it. But it's also easier to hit. It's closer and it's easier to hit. And then you've got like MEO, which is kind of also you might consider a sweet spot in the middle, which has the advantages of both. Similar latency to LEO, but a little further out and harder to hit, similar to GEO. So I think it's just like building a financial portfolio. Diversification automatically sort of increases your resiliency there.
Great, thank you. And let me ask Jose, are there any other additional satellite architectures that can add resiliency to existing networks? Anything that we haven't touched on? And you're on mute.
Any new emergency technology will reinforce the new architectures and the additional architectures already existing now. I think, for instance, one of the vectors to coming is what Campbell mentioning about the merging of technologies from satellite and terrestrial or 5G technologies, just in order to define new scenarios in which the new satellite connection and communication will be moved. That, for me, new architectural is a must. So not only to have in mind new legacy systems that you can already have, as Dave has mentioned as well from geo systems, but also you need to have more flexibility, and this flexibility will give you definitively to new improvements in architecture. These architectures can be implemented by the new IoT systems, by the new technology in communications, in packaging, in cybersecurity, in encryption. So all these emerging technologies will definitively draw new architecture solutions to implement the resiliency and networks.
Great, thank you. So something that gets a lot of discussion at various events at which I've attended are open architecture solutions and interoperability standards. Do you think that they would be beneficial to effective resiliency? Jose, let me start with you, and then we'll go to Dave and Campbell.
Okay, well, no, for me, interoperability, yes, will definitely help in the solutions. Open architectures should, open architectures should improve, but will have a less impact in the beginning, but in the coming years will definitely get speed on the contribution on the resiliency. Also, for me, it's an interesting point to set scenarios that could be dynamically interpreted and dynamically managed, and that for me it's a must that the use of AI should be implemented in all the processes that we are handling with architecture. The open architecture should be a way to define new standards in such a way, because if we do not have as Campbell mentioned, any standard that could allow simplicity in the evolution of the technologies, that will be a stone in the road instead of a wheel. So that I think that this should be considered in the two speeds. The speed of open architecture that will have less impact at the beginning, but will get speed. But interoperability for sure should be considered since the beginning.
Great. Dave?
Yeah, I think it definitely increases resiliency by allowing transition between different antennas and different constellations and teleports. If someone is using a proprietary modem or HUD technology that doesn't have interoperability with other modem or hub manufacturers' waveforms, then your options are severely limited to what teleports or ground stations you can utilize, and it prevents that opportunity to dynamically change or use a global NMS and seamlessly move between different orbits and bands if your antenna is even capable of that. I feel like when you really start talking about interoperability standards, the focus, at least for me, is on the modem side, because all the operators or all the manufacturers, of course, are going to have their secret sauce in their waveform. But I think that we really need to get to provide maximum resiliency for our customers is interoperability between those waveforms with one another.
Great, thank you. Campbell?
Yeah, I'm sort of going to hammer on the same thing at risk of sounding like beating a dead horse. It's standardization, I think, is critical, and kind of dovetailing comments that both Dave and Jose made here. Standardization does create flexibility and implicitly resiliency, in our opinion. Those standards and those the ability to leverage commercial off the shelf, obviously on the commercial side, if it's standardized, it's resilient because you can have something explode and you can very quickly replace it, and sort of to dumb it down to that level. But I think it really is that simple on a commercial level. Obviously, when you have the conversations along those lines, you make that point to a government stakeholder, it's a little bit more nuanced again. Government isn't traditionally used to using kind of commercial off-the-shelf chipsets or things like that. But with the new evolution in digital transformation of what these chipsets and things are going to be capable of, if government is willing to, from a policy perspective, move to that stance and realize that kind of industry is moving at a pace and is going to continue to move at a pace that government is just not capable of keeping up with, but it's rather about learning how to harness and leverage that speed of development that industry is creating. I believe that is going to be the smartest approach for government to take as we confront this sort of oncoming wave of digital transformation in Industry 4.0. It's kind of about you either embrace it or you get left behind sort of thought process. And so the key, I think, two big key aspects of that come to mind for government, what kind of approaches that they need to embrace are one, on the standard side. So if you're gonna leverage a standardized approach, you have to be involved in the standards bodies like 3GPP, because foreign adversaries are very involved either directly or through proxy companies. And if the United States isn't equally, if not more, involved, they're going to get left behind. They won't even have the option to harness those standardized technologies. And the other one is and we've already been seeing some really good efforts on this congressionally and legislatively recently, which is in terms of making sure that the United States has the industrial base to produce these things nationally, so that we can trust them, so that we can know them. And I think we're, if you're prognosticating on policy stuff now, sorry, but I think we're at a position, as this is all developing right now. We're at a great standpoint coming out of COVID for the United States to become a global leader in this new industry and creating these chipsets, and it just seems like a great opportunity to me, and it would create a resilient networks for the United States for decades to come. So, sorry.
All great points. Thank you. So we may run a little bit over, but we've gotten a couple questions from our audience that I want to make sure we have a chance to cover. And the first one relates to one of my favorite topics, which is spectrum. The question is, spectrum flexibility was addressed as a useful element, yet spectrum congestion looks to me to be a huge challenge to everyone in the near future as thousands of new emitters are orbited. Are you confident or concerned that technology and regulation are up to the spectrum management challenges? Dave, let me start with you.
I think my best guess to answer that off the cuff would be that I think that one of the things we touched on earlier, that a lot of the newer satellites will, the transponders won't be fixed to specific satellites. And then also, the transponders won't be fixed to specific frequencies, therefore allowing you to change as needed over a specific geographic area, as well as the ability, like we did touch on earlier also with the inter-satellite links, to route away from a geographic area where there may be frequency congestion and downlink somewhere else in the world. I think that, at least from a technology standpoint, I'm not talking about regulatory on the spectrum management side, but from the technology side, I think that those are two things coming that would help with the question. Over.
Great, thank you. Jose?
Yes, I have to be confident because really by the implementation of spectrum monitoring systems and implementing technologies that could help just to clarify and to make clear communication with the spectrum flexibility policies will be definitely help not only for the regulation point of view, but also from the operability point of view. So for me, I think that spectrum management will really take the challenge of all the emitters that will come in the near future, and actually they will manage in a dynamic way all the management that is required to have a low RF interference and to have a neat delivery of the signals that they are managing. So for me, I have to say that I am pretty optimistic that the spectrum will be a challenge, but will not be a definitive problem in the resiliency of the communications. Back to you.
Great, thank you. Campbell?
Yeah, Dave and Jose gave probably a more eloquent technical approach to the answer than I could give, and so in that regard, I am also optimistic that technically the technology is capable of dealing with sort of the coming spectrum storm, if you will. On the regulatory side, I may be a little more cautious. It is going to be complicated. You've got multiple governments and even international bodies simultaneously trying to figure those things out, and those bodies are going to have to move at the speed that the commercial side wants to move at, frankly. Otherwise, we're going to create problems for ourselves globally. I think all of the different players. But I think one of the keys there is going to be again, sort of thinking about diversity of spectrum and stepping back and thinking about maybe traditional approaches or traditional frequency bands or uses of frequency bands that we may have traditionally considered to be, the government tends to get stuck in one thing and want to stay there, but they have, there needs to be a comfort with change. And I think on the commercial side, we've seen like with the C-band, folks moving out of the C-band. The more that private actors were willing to do that flexibly and take a new approach, we've seen, I think, a lot of benefits come of that relatively quickly. And so if both private operators and government are willing to adapt, then it'll make the regulatory aspect of it easier as well. So I think it remains to be seen, but I can be optimistic about it.
Great, thank you. So I know we're over, but this is a really good question that I want to make sure you have a chance to address. Over G7, the US and 5 other countries talked about a satellite-based quantum technology encryption network. Can any of the panelists talk about integration of quantum systems for cybersecurity and any pros and cons they can identify? Campbell, let me start with you.
Wow, that's a good one. Now I see. I know you couldn't let that one go, Tom. Yeah, so we were privileged we participated in something that the Air Force Research Lab ran, they do run in different cohorts, the Catalyst Campus, for anybody that's out there that's sort of a smaller business interested in working with the government. Check out Catalyst Campus at AFRL. We participated in their Resilient Space Communications cohort about 2 years ago, and we were lucky to be in this cohort with another company that focused on precisely this, and learned a lot about it. In fact, when over beers one night, the gentleman who was in it with me, Dave, was explaining how sort of quantum encryption works, and I went home back to the hotel with my partner Dave, and I explained it to him, and I turned to him and I said, he's pulling our leg. This can't exist. This isn't possible. And then we Googled it, of course, like any great search for information does, and found out it is indeed true. This is spectacular technology. Our adversaries are sinking orders of magnitude more investment and work into it than we currently are. And if we don't get up to speed on it very quickly, we're going to be in deep, deep trouble even a decade from now, in my opinion. Leveraging on-orbit quantum encryption, I think, is whoever masters that is on a national level is going to be, I mean, leaps ahead doesn't even do it justice. It is doable from the technology that I've sort of seen. I would love to see it. It's admittedly not something that we are focused on right now, but we would love to sort of integrate it as the technology develops. It's sort of light load in terms of swap, and from a system design, and I think it's a critical technology that everybody, both commercially and especially governmentally, needs to be considering right now.
Great, thank you. Jose?
Well, yes, it's a good one, and definitively, the idea will be to implement the technology as they will be developed. But I think that they are in the very, very early stages, and they will say, as Campbell said, it will take some leaps to write out a resilient technology by using this new quantum technology of communications. For sure, if everybody defines a standard, everybody will help to develop the architecture and the technology faster. But I see that this will not be for tomorrow. And basically what we have is the problem to solve from now on. Maybe we can include this technology on the resilience pipeline, which is when it comes enough trustable and enough secure with enough interoperability standards and very, very well assumed by everybody. But for the moment, I think we are not close to get that point.
Great, thank you. Dave?
Yeah, I think it's not really specific to the satellite or onboard technology itself. I think if you look at what we're doing today, with encrypting the command and control and steering, and then also on the user layer, whether it's Type 1 encryption, IPsec at the router, or transec at the modem, all of these things, provides cybersecurity features today, which is, of course, is part of resiliency. And as the quantum encryption technologies evolve, all of those will have to evolve, right? All of the things that we're doing today is the same things. It's just going to have to be done differently to prevent it from being cracked. I would say that that's my high level opinion about it, Tom.
Great, thank you. Well, I know we've run over. I appreciate our panelists. Great discussion today. Thank you for all of our attendees for the great questions. I should note that last question came from a former intern from SIA, so hopefully that means that we played a role in helping to train him. In closing, I'd like to encourage you all to join us at our next webinar. It's going to be on Thursday, July 15th. And is entitled The Future Role of LEO Satellites for Combat Search and Rescue. So with that, on behalf of SIA, again, thanks to our panelists and thanks for our audience for joining us, and we look forward to seeing you soon. Thanks. Bye-bye.
Thanks, Tom.